Hello and welcome to Hacks. Today we are doing another VulnHub box and we are going to be looking at Vulnix. Vulnix, I did this box a while ago and I wrote some notes on it, but I never did a proper write-up or a video on it, but it's a good box for a number of reasons. It's good for enumeration for a start, but the main reason why I like this box is it teaches you about a configuration issue in network file system, NFS. Which is an important one, especially if you're doing exams, because it may pop up in one of your exams. And it teaches you how you can misuse that service or access that service when you're not supposed to be able to. So it teaches you a lot about NFS as well as reconnaissance and about sort of authentication methods as well. So without further ado, this is VulnHub Vulnix. So here we go. I've got the Vulnix host running and I've got my Kali virtual machine running. I've also got both of these hosts configured on the VirtualBox host only adapter. So that means that these hosts are the only ones in that network. I could have them on a bridge or a network adapter, NAT adapter, but then I could do a ping sweep and I would be finding devices in my own internal network. So I like to do it on the host only adapter. It doesn't mean they don't have internet unless you configure a different adapter, but it just simplifies things. So in order to discover the Vulnix host, this one here, what we need to do is we need to sweep the network for IP addresses, but first we need to know what our network address is. So if we just run ifconfig, you can see there that we have been allocated the IP address of 192.168.56.102. We also know that the subnet mask is 255.255.255.0, which means that the first 3 octets of the IP address are used for the network range. So we can do sudo mmap-sp 192.168, we can tab complete, and we can either do 02255 or we can do the CEDAR address of 24 because we know it's a 24 subnet, and we'll let that run. Once the scan comes back, you can see we've got 192.168.56.1, likely the default gateway. We've got 192.168.56.100. We've got 192.168.56.104, and then we have our own host there because we didn't exclude it from the mmap scan. So we can make a logical guess that this is going to be the target that we're trying to attack because the interfaces are the same. So we've got Oracle VirtualBox interface NIC, Oracle VirtualBox interface NIC. So let's grab this IP address and probe it with a TCP scan. And what I'm going to do for this is I'm going to add a few arguments so that we can check all the TCP ports, but we can also do a banner grab to get the version of it. We can do an OS grab to grab the operating system based on the responses from the mmap scan, from the responses from the services. It can deduce what operating system it is. But what I'm also going to do is I'm going to add an argument or a flag to the scan, which will run a bunch of safe scripts. They're less likely to cause any negative impact to the host, but they will return even more information. So for this, we're just going to do sudo mmap-sc-sv. So the first flag, sc, that's going to be run safe checks or safe scripts. sv is going to be determine version. Then we can do -st to make it do TCP. And then we can specify ports. So we're going to do all ports. You can do that as either -p or -p0. And then we're going to pop in the IP address. And I believe that's it. Let's wait for that to run and have a look at what comes back. Okay, the scans have come back and you can see we have port 22 open. That's SSH, the remote management protocol. We can try and brute force that later if we can't get anywhere with any of the other services. We have port 25 open, which is for submission and sending of email. It's SMTP, it's using a postfix service. So yeah, we can do some interesting things with that. We can send it via, we can get onto the port, send it via RFI requests and try to verify any of the users. We've got Finger, we've got 110, POP3, again that's going to be part of the mail service. You can see there's Dovecot. We have 111 TCP RPC bind. We have, I believe that's going to be something to do with NFS, if I'm not mistaken. We have 143, which is IMAP, which is another mail service. Again, it's better than POP. It allows you to synchronize your mailbox and calendars. Maybe not calendars, but your mailbox, rather than just downloading it directly off the server. Got some interesting services here. We've got 512 EXEC, don't know what that is. We have login, we have shell, so it might be worth throwing a netcat connection to these ports to see what they are. 993, so that's the encrypted equivalent of Dovecot or IMAP. 995, encrypted equivalent of mail service again. 2049, that's another NFS port. And we have a few others which I don't really recognize, but you could Google those and see what they are. So in order to start enumerating things about the system, I think I'm going to go in port order, starting with port 25. As I said, we could try to brute force SSH. There are other tools that allow you to enumerate users through SSH, but I feel the best thing we can start off doing is enumerating users via port 25, provided it allows us to do so. Now, the easy way we can do this is we can do it through a tool called, or a framework called Metasploit. There are other tools out there. You can use mmap, which has got an SMTP users enumeration script. There's standalone scripts that are written in Perl and Python that can allow you to do it. I believe Kali even has something called SMTP, or I believe there is a tool that you can install called SMTP user enum. But all I'm going to do is sudo msf console to load Metasploit, pop in my password and wait for that to load. It can take a while, so bear with me. Fantastic, and we're now in Metasploit. So what I'm going to do now is I'm going to search for SMTP. And what I love about this is the module that I actually want, or the module that I actually want is number 25, port 25, which we're attacking. So we're going to use 25, and as you can see there, auxiliary, scanner, SMTP, SMTP enum. Now if we do show options, it will show you what parameters are set and what parameters we need to set in order to use this attack. So you can see there we have our hosts, our port, threads, and user file. The user file is going to be our word list, the port is the port, and our host is going to be the target host. So we need to do set our hosts. It should be capitalized, but again, it's case insensitive in Metasploit, so you can use lowercase, but again, if you're working on Linux systems which are case sensitive, it's probably best to get into the habit of capitalizing where capitalizing is required, if that makes sense. So 192.168.56.104. Then we'll just check that that's been set by running options again. And all we're going to do now is we're going to run exploit. This may take a few minutes, so I'll pause the video and come back once it's done. So we have a user's word list, and I could start Hydra on it right away. I probably will in a moment. But we also have another service called Finger, which, if I'm not mistaken, allows you to enumerate users or something on the network. I'm not too familiar with it. I've not done that much enumeration of it before. But if we just do search Finger in Metasploit again, there aren't that many options. We probably want these auxiliary scanners here. So Finger users enumerates the users. So yeah, I'm just going to go with use one. And I've never used this before, but that's the joy of hacking, You find a new service, and again, you can see there, it's got our word list, so all we've got to do is set our hosts to 192.168.56.104. Now, there is an option to set this variable globally in Metasploit so that you don't have to keep setting it on every module that you use. Very useful, but we can cover that in another video, or another video based entirely on Metasploit. But I believe that's correct. Let's show options again, and then I'm just going to run exploit again. So looking at the results from the Finger enumeration, it does look like it's roughly the same types of users that we found in SMTP as you would expect. And we've already built a word list based on those users that we found from SMTP. So what we can do now is we can use that word list to brute force the SSH service. What I've done in advance is I've downloaded a fresh copy of rocku.txt, which is a known password list. It's a password list that's been built up from multiple leaks over time. Actually, I think it's from one specific leak, which was the rocku database. However, people have added 2 different lists, but rocku is the one that everyone uses. And what we can do with that, so we have a users word list and we have a password word list and we have a target and we have a port. So we're just going to do sudo home kali documents username.txt, because that is where our word list is for the usernames. And then we're going to do -P, not lower p, because we want to specify a word list for the password, and I'm using rocku.txt. Then we're specifying the host 192.168.56.104, and then we're telling it to use SSH. This sort of tells it to use port 22, and it knows it's the protocol. And all we're going to do now is we're going to hit return and let that run, and then we can continue enumerating other services in the background. So while Hydra is running, I've exited Metasploit. I did run into an issue on Kali where my mouse clicks stopped working. Just in case you ever run into that, what you can do is you do ps aux pipe grep and search for drag, and then what you might see are processes called drag and drop. If you kill those processes, your mouse clicks will start working again. Stupid VirtualBox doing stupid things, I don't know. Anyway, so we've looked at port 22, we've looked at port 25, we looked at port 79. Again, not really much we can do with Dovecot unless we're doing like proper exploitation. So let's look at NFS. NFS, Network File System, is like SMB. It is a service, should I say, not protocol, that allows you to share files across the network. And we can try to enumerate information about those shares, and we do have a good command for that, which is called showmount. And then you type E for exports, and then you do 192.168.56.104. And as you can see there, we have a share home Vulnix. And the interesting thing about this is that we know users reside in the home directory. So because we know it's home Vulnix, one can assume that the user to access this is Vulnix. And the reason why I say that is because if we can work out what the user ID is, not the username but the UID, we can actually trick NFS into letting us access this share, provided we have the user with the correct user ID. So all I'm going to do now is I'm going to make a directory in mount called Vulnix, which I probably already have. File already exists, and then I'm going to do sudo mount. You can see that I've already done it. Right, so if I was to just run this without the -o version 3, it wouldn't allow me to enumerate what I need to enumerate. So if I just do it anyway, then if we do ls-lash mount, let's try listing out Vulnix first of all. We should get permission denied. There you go. We can do it with sudo just to make sure it's not that. Fine, can't do it. If we list out mount, we can see there we've got the nobody group. And no matter what we do, we can just do ll. Yeah, it doesn't work. But if we do sudo, sorry, I cannot type today, unmount, mount Vulnix, and then we remount it using the -os version 3 command, because we want to use NFS version 3. And then we do ls-lash again and do mount there. What you can see is instead of having nobody, we actually have 2008. And what we can do with that information is we can create a user, because we know the user is called Vulnix. We've enumerated it through SMTP and through Finger. So if we create a user called Vulnix with the user ID 2008, NFS is going to be tricked by that, because that's how it verifies you can access it, is by the user ID. And once we can do that, we'll have access to Vulnix's home directory. So in order to do that, all we're going to do is do sudo add user. Then we're going to specify the ID that we want, which is 2008. And then we're going to say Vulnix, add a new user, and it wants a password. So I'm just going to use the password of Vulnix. And then I'm just going to hit return on all of those just to automatically create them. So now if I sudo to Vulnix, tell you what I need to do first is I need to remount the box, because I've rebooted my machine since I was last recording. So I need to do sudo mount, and the IP address has changed. It's 105 now, not 104. So we got the NFS version flag on there too. Sweet. So got Vulnix in there, and as you can see, we still can't access its contents with this user. But if we then sudo to Vulnix and pop in Vulnix's password, what we can do now is we should be able, what am I doing? ls sh mount Vulnix. So as you can see, I can now list out the contents of that directory. And what we can do is, if we create a directory on there called vulnix.ssh, what we can do is we can pop some keys into this .ssh file, and then so we put the public key in the .ssh authorized keys file, and then we can use our private key to SSH to the box as Vulnix. So let's have a look at doing that. What you may need to do when you do your SSH key gen is specify the type SSH RSA, and the reason why is because this box is using a algorithm signature which is no longer supported. So if we do SSH -keygen -t for type, and then SSH -RSA. It'll ask us where we want to put it, so I'm just going to give it no passphrase. Sweet. So that should now be in our I need to change to my home. Yep, so those files are now in my .ssh folder. So if I cd into there just to make things easier, and then what I can do is I can cp id _ rsa .pub into mount vulnix.ssh, and then I want to call it authoriZed _keys. And if we just now cat out id _ rsa.pub, and then we cat out mount vulnix.ssh authorized keys, they should be the same. Yeah, starts with 4 A's, ends with VC. Brilliant. So now that that's in there, we can SSH to the box theoretically in order to access it as the Vulnix user. However, we need to add a few arguments onto our SSH command in order to tell it to support those key types, the SSH RSA key types. So we're going to do SSH -o, and then we're going to do pub key accepted key types space plus SSH -RSA single quotation mark, and then we're going to do -i, and this is going to specify our key, ID _ RSA, and then we're going to say Vulnix at 192.168.56.105, because again the IP address has changed, and fingers crossed this should get us straight onto the box. I've actually been struggling with this bit for quite a while, and I didn't know about it. Yes, and there we go, we are now on the box. So what do we do once we're here? Well, there's a few things we can check immediately. So we'll check what files are here. There's nothing here. We can check home. See, there's user and Vulnix. That I believe we were trying to brute force one of those users earlier. We can check history. There's not a lot going on. Or we can do sudo -ll. Is that right? Okay, so we do have some sudo commands. We don't have Vulnix's password, do we? Oh, you can see there. We can run sudo edit etc exports, and what the etc exports file is it determines what shares are shared through NFS. So Vulnix would be in there. We don't need a password to do that. So if we go into sudo edit etc exports. So what you can see in this file is the exports that are currently shared by the server. This is the Vulnix directory that we've been playing with, popping our keys onto there. But what we can do is we can tell it to share root, which is going to be the root directory's home folder. Then we're going to put the star, and like above, but this time we're going to do read write, and then we're going to do no underscore root underscore squash, so that we'll be able to access the root files. Then we're going to write and quit that. And that should allow us to now run show mount and see the root. The problem is, in order for these changes to take effect, the machine needs to be restarted. And we don't have the ability to reboot the box. We need to be root, and we can't reboot because we ain't got the password for Vulnix. What you could do in a real life situation, if you were hacking and it wasn't a client engagement, is you could do a fork bomb or something, which I'm just googling how to do now. Yeah, so it'd be something along the lines of that. What that would do is that sort of recreates a process. It keeps spawning processes that use resources, and eventually it will cause the machine to have its resources completely exhausted, and it will hopefully fall over or reboot. And then either, if it doesn't automatically reboot, if it isn't configured to automatically reboot, hopefully some data engineer will come along, press the button, turn it on, and then find out that you fork bombed it, and he'll be like, oh, we need to secure it. But in this case, all I'm going to do is just reboot the machine manually, and then we'll have a look at the exports. So the machine has been rebooted, so now we should be able to do sudo show mount -e 192.168.56.105, pop in our password, and you can see there we have the home folder for the root user shared. So what we should be able to do now is if we make a directory in mount called vulnroot, and then we sudo mount the IP address / the root directory mount vuln, again using that NFS version 3. And then what we should be able to do is if we sudo ls, I should be able to list out the contents of root, which there we can grab the trophy. Trophy.txt. There we go. That is essentially the box complete, but don't you feel a little bit upset that we didn't get a shell on root? Well, let's change that. Sorry, I'm just putting some notes onto my blog quickly. Yeah, let's just throw that there. Okay, so we can do exactly the same thing that we did with the Vulnix user. Now I believe I have some keys already created in my .ssh. So all we should really have to do is copy over the public key to the authorized key file in the root directory, in the root's SSH directory, and then SSH as the root user using the private key. If you don't have an SSH folder in the vuln root or the root directory, just create one, and then you can do sudo cp get rid of that directory, id_rsa.pub into mount vulnroot.ssh authorized keys. So you're just copying your file to there and giving it the name authorized keys. Fantastic. So now we should be able to do sudo ssh. Then we got to put the special flags on again, but you can see there I am then specifying my key id_rsa and then the user root at 192.168.56.105, and hopefully when we hit return we are root on Vulnix, meaning that we have owned it. Now, when I first did this box, I blitzed through it pretty quickly and I didn't have any issues. On revisiting it, I had a lot of issues with the depreciated RSA SSH, a lot of issues with the root squash. That's why the video's cut up so much, is because it's taken me far longer than it did last time, due to a number of issues that I've run into and just me being generally rusty with this type of things. You know, I've not done proper exploitation for a long time, but I really enjoyed this box. Well, when I first did it, I really enjoyed it. It's a fun box which teaches you an awful lot about NFS and ways you can get around sort of authentication with SSH keys if you don't know the passwords and things like that. So yeah, I recommend giving it a go. It's on VulnHub. You can download it from there. I will put the link in the description. Spin it up on the virtual machine and have a crack at it. Anyway, thankfully that's over. Thank you very much for watching and kind regards.